due to the name of most famous mathematician Euler or Euler, E-U-L-E-R. After changing this variable, we can now apply the standard limits we have discussed earlier, and numerator is written now. First you think, if we put the value m equal to 0, denominator will not vanish. Therefore, I can now put the value m equal to 0. I have mentioned in the earlier episode that two standard limits. Number 1, limit extends to a x to the power n minus a to the power n at the numerator and x minus a at the denominator, that is equal to n a to the power n minus 1. Then limit extends to 0, sin x by x is equal to 1. Then there are few more standard limits. I have written here 2. First, limit extends to 0, e to the power x minus 1 by x equal to 1. Then limit extends to 0, log of 1 plus x divided by x equal to 1. Remember one thing, the base of logarithm in case of calculus is e. I have mentioned here e, base is e, that is natural logarithm case. Next we have limit x tends to 0, 1 plus x whole to the power 1 by x, that is equal to e. E is Eulerian constant. Later you will learn that value of E is due to the name of most famous mathematician Euler or Euler, E-U-L-E-R, Eulerian constant. These are three standard limits which are used, though those are considered in later part. Actually, according to the syllabus framed by state board as well as CBSE, the first two already I have mentioned are in the syllabus of class 11, but we have to learn these standard limits also. Next thing, one most important thing, in case of x tends to infinity, you will get limits where the independent variable tends to infinity. What we do? We change the variable. As taking as z equal to 1 by x. Since x tends to infinity, that means a large quantity which is greater than the large quantity you can think. Therefore, z tends to 0 as x tends to infinity. After changing this variable, we can now apply the standard limits we have discussed earlier. Now I take few sums where variable tends to infinity. Limit n tends to infinity. The first sum is limit n tends to infinity. Expression is root over n plus 1 minus root n. Already I have mentioned that you have to change the variable. Let m equal to 1 by n. Therefore, m tends to 0 as n tends to infinity. Therefore, given limit is equal to limit m tends to 0. Now we have to replace m by 1 by m, then 1 by m plus 1 minus root over 1 by m. Now we simplify. Limit m tends to 0. Both denominator will be root n. Now we get the irrational form. Also, by putting n equal to 0, we find that numerator denominator both vanish. Therefore, in the next step we have to rationalize. I have not rationalized root n. Actually, we shall get m at the numerator. That is why I have not multiplied both numerator and denominator by root m. Next step will be m tends to 0. As the product is 1 plus m minus 1, then 1 will be cancelled. I write directly m. Then this is root n. Now I cancel. And numerator is root n. Now, first you think, if we put the value m equal to 0, denominator will not vanish. Therefore, I can now put the value m equal to 0, then numerator by 1 plus 1, therefore result will be 0. Thus, finally, the limiting value is 0 for first sum. Now, I solve number 2. Here also we put y equal to 1 by x, therefore y tends to 0 as x tends to infinity. then it will be limit y tends to 0, 1 plus 1 by y plus 1 by y square minus 1 by y. Then we simplify. The simplified form will be this one. Numerator 1 plus y square root minus 1. Now we find irrational at the numerator. We rationalize that. Then limit y tends to 0. The product after simplification will be y plus y square. I take y common factor. Now I can cancel y, mention since y not equal to 0. Then finally we put y equal to 0, and what we get? Numerator 1 plus 0, denominator 1 plus 1, that is equal to half. Thus the result is half. You see, first step we have substituted x as 1 by y, or y is equal to 1 by x. Then after simplification we have got this form. Since numerator is irrational form, also putting y equal to 0, we find numerator and both vanish. We rationalize the numerator and get the final step, this one. Here we have cancelled y since y is not equal to 0. Then finally we have put y equal to 0 and got the limiting value half. Up to this, in this class, in the next class, we shall work out few more sums on limit and then proceed. Thank you.